you, do you know what the R squared coefficient represents? Answer. Can you hear me? Okay, you don't know what it is. The R squared coefficient is a coefficient that has no unit. It has to be very close to 1 to say that your values are displayed on a linear line, on a straight line. Like here you see that you have some experimental errors. Here you have more experimental errors, and you have some experimental errors and very minimal errors. In this case, you see R squared is very close to 1. This means 1 is the perfect straight line. This one is really bad. You see a lot of errors. So you see 0.8555. So R squared is like a testing coefficient. It tells you how close you are to a straight line. Like if I go to this one, R squared will not be close to 1 at all, maybe 0.5. I want to show you this one. Those values are not even a straight line. And the student who did the straight line, the linear function, is actually a student who is very confused because the R coefficient or the R squared coefficient is very far away from 1. It has to be 0.9 or something. So this shows that your points do not represent a linear relationship, okay? So now you do understand what linear relationships are, and you know how to write the equation of a straight line. All right, back to the content. How do we calculate the slope? You tell me, if I give you a graph, how do you calculate the slope? Like in this case, how do you find the slope? Or maybe in this case. Did you say delta y over delta x? All right, you do this in math. The delta y of who? Like here you have so many points. Which points do you take? The forest too. Yes, I heard this in high school. Yes, I heard this in high school. But my dear Carl, Dana, Joseph just joined us, and Nazir and Leah. You guys, you have to be careful because most of the points we have here are not even on the line. Look at those points. In this case, none is on the line. And usually when they say take the farthest points, they actually mean you have to pick 2 points on the line. So yeah, but remember that our job is to find the line. Like in this case, you take measurements. Where's my Excel sheet? This one. These were measurements taken using, I don't know, a ruler, a multimeter. So where's the line? I don't have any line. I need to find the line. So I find the slope first, then I find the line. So if you ever think of doing delta y over delta x, remember this Batman face palming himself. Please don't do this. Okay? Don't do this because this can only be used if you pick 2 points on the line, and in your case, you do not have a line. So what do you do instead? You have 2 methods. You either use Excel, very simple, and or use your calculator. Excel, actually, you fill in, select the points, and Carl, I think my voice is interfering on your, so if you can mute yourself unless you want to say something. Yes. So you just have to select the points and pick a scatter and insert equation. Done. Once you have the equation, you have the slope. And if you have the equation, it would look like this. You can add the R squared coefficient, and it will show you the best fit, meaning the average line in between. All right. Let me show you how. We already have this. What you do is you right click, add trend line. Trend line is the average best fit line. You see the line? It's in between. It's not touching any of the points. Do you see this one? So it says linear, and then you pick display equation, and you pick display R squared value. Okay? And I'm gonna close this window and look in here. I'm gonna make it bigger for you to be able to see it. Yes, 20. Now you can see it. It shows you the equation of the straight line along with the R squared value. Who can tell me what the slope is? No, this is the y-intercept, not Dana. So the slope, yeah, is the one before the x, and r squared is 0.95. Is it a good coefficient? Does it show a superlinear relationship? I don't know. I would say it's close to 1. It's not super close to 1 though. It's acceptable. All right? Cool. So with Excel, it's one click away. You're one click away to write the equation. Cool. Now I'm gonna go to this slide. How do I use my scientific calculator to find the linear regression? I'm gonna remove my earphones. I hope you can still hear me. I prepared a video for you this morning, how to find the slope using a calculator. Okay, I showed you my calculator. Let's watch this again. Please stop me if you believe you have a question. Hello everyone, this is an example where you have the x-axis, the x values, the y values. The x is in seconds, so definitely it's a time. The y is in meters, so it looks like it's a certain distance. And you have some measurements done. Each measurement has two significant figures. And you're supposed to plot y versus x as usual and then find the slope. Is this linear or not? We don't know yet. So how do we... Sometimes we learn how to find the slope using a calculator because maybe in the midterm, you will not have your Excel or laptop on you, you know? And it's really not difficult to do that on the calculator. You have a special function for it. Linear regression, and how do we assess if our linear regression is linear, our line is linear or not, our function is linear or not. So you put your calculator on, you go to mode, and then you go into stat 3. You go into a plus bx, which is the equation of a straight line. A would be the y-intercept and b is gonna be the slope. So 2 is the option I need to pick. You plug in the values in the table and make sure all the values are in x first, then y. So 1.1 equals 2 equals 2.9 equals 4.2 equals, and then I'm gonna go into the y-axis. Yes, and 2.0, 4.4, 5.9, and then 8.5. All right, when you're done, there's a very important step that you shouldn't miss. You should click on AC. Then you do Shift 1 to go into the stats. Go into regression, which is item 5, and here you will see displaced A, B, and R. A being the y-intercept. So how about I go into A and I write it down. It's so the y-intercept, let me call it A, is gonna be negative 0.03. Okay, so for you to be able to see it, and then Shift 1 again, regression, go into B, that is my slope. My slope is gonna be 2. Do you notice that it's bx plus a, so B is the slope, okay? 5. And then Shift 1, regression again, R is the coefficient of regression, and I'm gonna explain again what it means. So 996. By the way, this guy R has no units. It's a coefficient, it has no unit. The closer to 1 it is, the more linear your function is. So as you can see that we're definitely dealing with a straight line since R is 0.996. Now this is the slope. It's very important to post a unit for the slope. The unit for the slope is gonna be meters per second because it's the unit of y divided by the unit of x. The y-intercept has a unit of y, which is in meters, and you see it's negligible, basically, or very small. So if you write the equation of a straight line to be y is equal to bx plus a, you're gonna see it as a straight line that would be passing by a point very close to the origin. And this is the slope, and this is how we do the work on our scientific calculator. All right, you guys, do you have any questions? I want you please to put your calculator in front of you and to try this. Watch the video again later and pause for every step and try it on your own, okay? If your calculator is different, please let me know. I can help you with the steps.
Doctor?
Yes?
How can we find the video again?
Yes, I will send it to you. I'm gonna put it on Blackboard.
Okay, thank you.
Either as a video to download or maybe a YouTube link. Maybe I'm
Okay.
gonna throw all these videos on a YouTube channel so I can send you the link. Cool? All right.
Oh, good. Thank you. Okay.
Yeah.
Good. Good.
Okay, I'm gonna minimize. So basically, now if I go back to the content, you know how to draw a graph. You know the difference between linear relationships and not. You know how to calculate the slope using Excel or using the calculator. Now, why do we need the slope? Okay, that's item 4 that is actually here. No, you have an example to try. Try this out on your own. Use Excel and use your calculator to find the resistance of your circuit. So you are given some values for I, some values for U, and your job is to plot something versus something and to try to find the slope and deduce R from it. Do you know Ohm's law or the relationship between I, U, and R?
Yes.
Can you
Yes,
please
we know.
remind
We
me
know
and
it.
remind your friends? So it's U equals R times I. We just did it, didn't we? So we just did it. So
Yep.
this one could be your y-axis, this is your x-axis, and this can be your slope. All right, think about it. Now I'm gonna give you 3 examples. F equals MA. And maybe ask Nazih. No, Joseph. May I speak to Joseph? And maybe put my earphones back on. Yes, Joseph, are you still with us? No? Okay, back to Joseph is typing. How can I find it again? Joseph. Okay. Anyway, Joseph cannot talk, right? Is this what he's saying? So maybe I'm gonna ask Nazih to talk to me. So Nazih? All right, yes. So F equals MA, F is on the y-axis and A is on the x-axis. What would be your slope? Okay, but A is the x-axis. All right, so M is the slope. Thank you so much. Nazih, if you want to stay with me, I want you to consider this equation. T is equal to 2 pi square root of L over G. You see that T and L are not proportional. They will not give you a straight line. But if you plot T squared versus L, and maybe I can use this document. Do I still have some space? Yes. Yes, I want to do this. Let me fetch some space and write it down. So, and maybe move this a bit so we can see the equation and move this a bit. Okay, so I'm gonna use red. So T squared, can you help me write T squared? Is 4 pi squared, yes. Okay, L over G. I can put G here or anywhere. Okay. Now back, okay, so if this is my X component, this is my Y component, what would be my slope? Exactly, so once you find the slope, you say the slope is equal to 4 pi squared over G. So G will be 4 pi squared over the slope. So that's why we find the slope, because indirectly it would help me find G, and G is the strength of the gravitational field. This is awesome. Now I'm gonna ask a difficult question. I don't know if Carl can help me out. Carl, you have U to be equal. Let me try to fetch some more space. Okay, I should remove the pen first and create some space. All right, U equals Ri. This is what it says. So U equals Ri, the famous Ohm's law. Okay, I'm gonna take I to be the y-axis. So this is your y-axis. So this is y and this is x. What would be the slope? What do you think? Maybe write y equals bx or mx. Can we try to write it down? So I is equal to u over r, isn't it? Okay, so if this one, maybe use yellow. If this one is the y and this one is the x, what happens? How would you draw y equals to constant over x? Do you think it will gonna be linear? It's a hyperbola, so it looks like this. It looks like this. It's called an inverse relationship. Okay, so this is not a straight line, and no, we cannot find a slope using this one. So the question here is, what is the slope in case I is on the y-axis and r is on the x-axis? There's no slope because we cannot, it's not a linear relationship. Now I'm gonna ask Dana. And Carl, you're gonna mute yourself. Yes, Dana, how would you plot this one to be able to get a linear relationship? Like pick y to be your I and x to be your r, it did not give me any relationship. What would you plot to get a... Yeah. Okay, but u is a constant in this experiment. Like you have a generator. Yeah, you have to plot something related to r and I. Look at this one, it would help you. We cannot plot I and R. We need to plot, and then which, but if you switch those, you will end up R equals U over I. Yes, of course. Okay, so let me create some space and explain what Carl means. Look at those letters floating. This is so funny. Okay, so Carl is trying to say, since I is equal to U over R, right? U over R, I can simply write this down as U times 1 over R. And what I can do is the following. I can take this to be my Y and this to be my X and end up with Y equals to a constant that is U times X. And this is a superlinear relationship. So instead of plotting I versus R, I plot I versus 1 over R. Dana, does it make sense to you? All right, so this is a way to flip a certain relationship. So far, we learned two methods. Let me minimize all these windows. So far, we learned two methods. How can I reach this one? Okay. Okay, so far, we had this example. Where is it? This one, showing that we had a curve and we made it linear by simply plotting something else. And the hyperbola, with the help of Carl, we plotted something else and we ended up from a hyperbola to a straight line. And I love this. So now you know that scientists can make from any relationship a linear relationship, okay? So back to our content, removing the faces we have here. So a graph is a communication tool done. Why linear relationships and how to make any relationship to become linear? How do we calculate the slope? And what is the slope needed for? What does it represent? Now, concerning the error on the slope, your class is required to know how to do this, but it's not a very important requirement. So I'm gonna see how much I can postpone it, and if I can remove it from our outline, I'm gonna check with the course coordinator. I don't want you to worry about it, okay? What does it say? Let me tell you briefly. It says once we find the slope, what is the error on the slope? Like in this case, You see, you have a lot of experimental errors because the points are very far. And here you have a small experimental error. Like here you find the slope plus or minus a big error. Here you find the slope plus or minus a small error. How do we find the error? It's not difficult. You just have to follow an equation. It's only a big equation and it has so many parameters. And you worrying about this will not help you focus on other stuff. So let's focus on what we have. Let's make sure we learn how to solve the mini assignments you have between the slides. Now a question for you. I want to do something and you tell me if you like it or not, okay? I want you to post your answers on a discussion board. Let me show you where. So where is my Blackboard? This is the Blackboard of your class and this is the discussion board. So far, you see your first assignment. Dear fellows, please solve the questions in our first PowerPoint presentation and post your final answers in this forum. Let me see if you got the point. You did not receive any notification of this one? Who received a notification of this one? Okay, so basically I did not write it in the announcement. I wrote it under discussion board and you were supposed to receive an email about this. You did not? Yeah. No, we don't have, usually we don't have homework. Usually you have a lab report and you will know about it. Okay, but would you mind posting your answers here? This assignment is not graded, right? And it's okay if you write it down and your friends can see the answers. And I would like you to do mistakes and maybe your friend would say, no, I got a different answer. And maybe a third friend would say, let's fix this together and discuss it as a team. Would you like to do that? We are a small class. I think it's nice to discuss our answer only for this assignment in this forum. Do you like it? Yes, do you want me to keep it? All right, so I'm gonna edit this one. I'm gonna say solve the questions in our first PowerPoint and in our second PowerPoint presentation and post your final answers in this forum. You don't need to show all your answer, just the final answer. And if everybody agrees, we say agree. And if you got a different answer, you say I got a different answer. And we can debate it. Okay, I think this is cool. Next time I see you, I'm gonna start with the first experiment. I already recorded 2 experiments from your class. I'm gonna show you a video of the equipment I used and the procedure I followed and all the measurements I did. I'm gonna show you the lab report and explain how you can fill in the lab report, and then I will give you a week to do it. It will be individual work and you will have a week to submit your work. And I'm gonna create somewhere on our Blackboard for you to submit the work in a private manner so nobody can see it. And I'm gonna correct it and give you a grade. So for this PowerPoint presentation, first and second, this is not graded work. It's only a discussion to make sure you guys got the point. And starting lab 1, everything is gonna be graded. Is that clear? On the thread? Okay, let me try. You go into the forum, create thread, okay, and okay, let me check again. There is a way to click on it. Yeah, if I go into your first assignment, what happens? Yeah, I'm under your first assignment, so I can create a thread. I'm gonna write waiting for your answers, okay, with a question mark here. And I'm gonna say submit. By the way, I can attach a file, but no need to, just write the answers, question 1, question 2. So now I'm under the forum, your first assignment, there's an answer. You can go in and maybe give me 5 stars or reply to me. Okay? If I go into this one, okay, can I reply to myself? I can reply to myself. I can delete it. I can edit, maybe change my answer. I can quote or maybe tag someone or reply to myself. Like maybe this is Carl. I would reply to Carl and tell him, excellent answer. Or maybe I can say, I do not agree with you. Or please explain. Would you want to try it? And by the way, I think we can use this if you guys have issues. Maybe we can use it to discuss it as a team. Because your mistakes and your answers would help everybody else. Don't you believe so? Yes? All right. I'm done for today. Let me know if you have any question. All right.